Hi, I'm Stella. I'm a product manager for Configit Lab. I've been at Configit for 3 years. Configit Lab is an initiative exploring new technologies. We're a team doing potentially slightly more risky innovation, but with a potentially more long-term outlook. Before Configit, I used to be a chemist, so yeah, apparently even when moving into software, I still work for a lab. So yeah, today I'm going to talk about what we're doing with Gen AI and how we think it can help with product modeling. Okay, so when I say product model, what do I mean? So our customers, they come to us needing to build a configurator for highly customizable products. They want this configurator to perform fast, and they want it to be 100% accurate. Their products are so complex and have so many possible options and combinations of those options that it's way beyond being hard-coded, and they need a rule engine to run in the background. All the information required to build this configurator and for the rule engine is what we call the product model. So it's got nothing to do with 3D CAD drawings, but it's all about the information that it describes the complexity of the configurating of the product. Okay, so how does a rule engine work? So first, you need to start by defining some variables. So I call these variables, you can call these characteristics, options, or families, this dark blue part, and then their possible values or choices. And this is essentially just a list of possible, yeah, it's just a list basically. Then you need to come in and define some rules to constrain these variables. It can be tabular rules, or it can be more of a simple if then else kind of structure. So for example, if someone said only blue in France, there's a couple of ways that you can interpret that statement, but the way I've interpreted here is that if the market equal to France, then the color has to be equal to blue. Okay, so once you've defined your variables and some rules, we compile this into a virtual tabulation. That's what our technology does. And then you can ask some questions, such as, okay, given these rules and some pre-selections, what is possible, what is not possible, is this configuration possible, that sort of thing. Okay, so your input is very structured, your rules are predefined, your output is deterministic and fairly transparent. You can quite easily reverse engineer why you got a specific response. And this is an example of good old-fashioned AI. Go for AI. Another famous example of good old-fashioned AI was Deep Blue, the computer that beat Garry Kasparov at chess in 1997. Yeah, and it's maybe not a coincidence that Configit was founded 3 years later. But you didn't join this tech talk because you thought I was going to talk about old-fashioned AI. You thought I was going to talk about generative AI. So, okay, quick background on generative AI, which is a form of deep learning. So, in order to do some deep learning, you first need a massive data set. And then you need to vectorize this data set, which means converting it into numbers, basically. And then you train some deep neural networks. Okay, so if you Google neural networks, you often see this sort of picture. I don't find this particularly self-explanatory, so I'm going to give you a quick explanation as to what you're seeing here. People like this picture because it's supposed to represent how neural networks look a little bit like the neurons in our brain, and how it's inspired by biology in that way. But here we go. I said you had to vectorize your massive data set. So imagine that your input is a vector, then each circle here represents one number in your vector. You then have to, you then multiply this vector by a matrix of weights, and basically each arrow represents one number in that matrix. And that transforms it into another vector. You also add another vector of biases, and then you apply an activation function to the whole thing. Basically, what you're doing is transforming your input vector into a new vector. And in truth, you have more than one hidden layer. You often have, in a deep neural network, you can have many, many, many hidden layers. And you do this transformation to go from one layer to the next layer to the next layer. Okay. So when you say you're training a neural network, what you're essentially doing is optimizing your weights and your biases. That's what you're doing. Now, I'm telling you all this just to say that what you end up with is essentially just a massive array of numbers, these numbers that you've optimized and beat. And so compared to the amount of data that you put in at the beginning, you're essentially left with a sort of floppy disk of numbers, which is representative of how to use your neural network. Okay, and then so you have your AI model, and now you're going to deploy it, and you're going to give it some new input that's not seen before. It passes through the neural network, and it computes using these weights and these biases a probabilistic, most probabilistic output, the highest probability output, and that's what your response is. So that's deep learning. But what happens, I think that's been around for a while, and what happened more recently around 2017 is we got transformers. So this is a type of deep learning model architecture. It's where the T in GPT comes from. And this now means that the architecture now means that you're capable of processing sequential data like text. So your massive data set can now be a mega massive data sets of text. And because it's sequential, what now means the information that isn't lost is any link between the first word and the last word of the sentence, or indeed the first sentence in the body of text and the last sentence in the body of text. That context is not lost. So you can find patterns that would just not be able to be found before, links between words that you couldn't find before. These transformers also meant that you could now do your training processes in parallel, so they're just way more efficient, way more scalable. And what this allowed was to do deep learning on almost the entirety of the internet. And the output are these large language models. Okay, so now if your AI model is a large language model, when you deploy it and you give it some new input and it gives you some output, that is essentially what ChatGPT or Claude are doing. So in these large language models now, the data is essentially that you put in is unstructured because it's text. It's all about pattern recognition, and the output is probabilistic. Okay, so this has led to this generative AI boom. 2 years ago, the companies that I list here on the right and apps, you'd either never heard of them or they hadn't existed. But nowadays, you've probably all at least played with ChatGPT at some point. I asked ChatGPT what is the most common use of ChatGPT, and the #1 response was writing emails. So maybe this is the sort of thing you've done. You need to write a difficult email along the lines of, please read what I actually said and answer the question, and you can get ChatGPT to write that in a more polite and eloquent way. The other thing that you can do with Gen AI that people like to play with is generating an image. So here I've generated an image of how I would like my baby to behave when we go to the beach. But what is really powerful and really interesting about this is that I use the same large language model to create this email as I did to create this image. So my point here is that the boom comes because Gen AI is becoming a sort of general purpose AI. It can do many, many things. Yeah, so nowadays it feels like you get a new headline, a new advancement in large language models every week. But there's two that I want to draw your attention to. One is that these large language models are getting really good at writing code. And the other one, potentially more recent, is that these large language models are getting better at reasoning. They can now answer mathematical problems. Okay, so this leads us to the question, okay, if these large language models can reason over logic, will it take over? It's a good question. So then I take us back to the workflow that we currently have and with our customers, right? And they get value when they have their end configurators. So here on the right here, lots of different types of configurators. It could be engineers need to configure, salespeople need to configure, your end customer wants to configure when they buy. This is where they get value, right? And they get this value if it's a configurator. It's fast, but also specifically if it is 100% accurate. And currently they have to put a lot of work into creating product models for this to work. But the point is customers are willing to put some time and money into building product models, because in the end, it is way more costly to accidentally build something they can't sell or to sell something they can't build. And this just shows how important the 100% accuracy is to them. And so the deterministic output of good old-fashioned AI is actually really important, and it works perfectly well. And even if these large language models, I mean, they're currently not there yet, but imagine they got really, really good, they'd never quite be as fast, and they will always be probabilistic, always. So I think good old-fashioned AI is here to stay there. However, any other part of this workflow that you can see on this slide, pick any other arrow, could be augmented with Gen AI. So we have picked potentially the hardest part, but the most fundamental part of the product model, which is the logic part that I talked about earlier, to work on this first arrow here. So how are we going to do this? How are we going to get Gen AI to help us out here? So I mentioned that large language models are getting better at writing code. And it just so happens that, a product model can essentially be expressed as a piece of code. Many years ago, Configit developed a domain-specific language to represent its product models. At the time, it was called the Logic Model Language, LML, which is potentially a little bit too similar now to Large Language Model, LLM. So we may have to change the name in the future. But here we go. Here is a representation of a model, which, by the way, I generated with Gen AI. This is a model for an MRI machine. You can see it lists some variables and its options, and then we have some rules, the tabular type rule, and this is an if then else rule. But of course, our customers aren't software developers who spend their life in dark mode. They're not going to want to look at this all day long. Okay, so how do they currently model? People often think that configurable products are modeled by one or even a team of modelers. And although this is principally true, they do most of the authoring, let's say. The input comes from all the different departments in a company. It comes from product managers, engineers, legal, sales, logistics. They all have to provide the data that eventually gets inputted into the product model. They give that information to the modelers. Okay, so what does the modeler then end up having to do in order to do that? Well, first of all, they have to learn how to use our tool. There's quite a lot of manual data entry. They have to be the gatekeepers of the data, making sure that product dictionaries are adhered to, this sort of thing. They need to do the interpretation, because all the input that comes from the different departments. They all speak a slightly different language. They have maybe a slightly different way of representing some logic, and the modeler needs to understand what the hell they're being told before they can input it into our system. And they basically need to develop a certain rule writing expertise to know how to best represent that piece of logic using our syntax. So the output of all this is that the initial modeling part, the initial brainstorming or the initial discussion between the modeler and the engineer, or the modeler and the product manager, the brainstorming, as I said, it often happens here. Why is that? Because Excel is very simple and flexible. It's very easy to add an extra column. It's very easy to copy and paste and move your data around. No one needs to learn how to use Excel. Most people come out of high school already knowing how to use it. It's very collaborative. Multiple people can easily see and edit the same spreadsheet, and everyone already has access to it. Almost all companies pay for a Microsoft license. But Excel simply isn't built for structured rule-based modeling. That's why people transfer a lot of that data into our tool. Yeah, you can't make a configurator out of Excel, at least not a very fast performing one. It's not going to be accurate. It won't scale. If you do try and scale, it quickly becomes unmanageable and error prone. So what we want to do is we want to try and address the issues that force people to end up basically establishing bad working practices. That's our vision. We want to build a tool where, for example, as you create your product model, you can instantly see it in a configurator format. Quite often we hear that, okay, a product manager comes to a modeler and they say, okay, this is the data that we have, this is how the product is. And the modeler goes, okay, and then they model it, and then they test it by themselves, and then they validate a little bit, and then okay, and then it gets put in the final configurator, and then that's when the product manager comes back and they go, no, that wasn't quite the behavior that I was looking for. That's not what I meant. So we want to get rid of that. We want no more waiting. We want everyone at the company to be able to see what the configurator looks like for the current product model now. We don't want anybody who's modeling, whether it be an engineer, modeler, or product manager, we don't want them to be doing tedious data entry. Modelers should not be clerks. They should be focusing on testing and validating the logic. We want a unified communication. We want the AI to take care of that. Product managers and engineers, they can speak a very different language. And we want the large language model to basically allow them to continue speaking in their different ways. I mean, in some companies, they might actually literally speak different languages, and that should not be a problem. We want to get rid of that barrier. We would like to maybe build in some best practices. So what is the best way of writing this rule? And when I say best, I mean for performance, for avoiding unexpected behaviors later down the line, when you add more variables or rules, yeah, that sort of thing. And we would maybe like it to be more bespoke to your business. So if you have company-specific naming conventions or product dictionaries, we would love it if it could ensure discipline without someone having to be that disciplinarian, I guess. Okay, so now I'm gonna show you a couple of videos of some demos of where we are, because we haven't achieved all of those things, but we are on our way. So the first one, the first video I'm going to show you explains a little bit more what I mean by the instant configurator preview. Okay, let's see if I can play this video. Okay, so here I'm on a website. And I scroll down and I find something here. This is very simplistic, but it shows you some information that maybe you would prefer to see in a configurator, or at least it would be a start. So I take a screenshot, I paste it in, and I say, okay, can you create a model from this? And the first thing it does is just extract the information from the screenshot and summarize it. It returns it, and you can check that it more or less matches what you want to say. And then you say, okay, I want to generate a model from this information. You can see here that it is generating the domain-specific language that we have, that we call LML. Once that's done, I show a couple of things that we do with this model from our Copilot, which is that you can create a work item. So this is a way of getting the information created here into our current modeling tool called Ace Model. And in Ace Model there, this information could be reviewed before being promoted to the main data, as it were. So you're not just you can't accidentally add things that haven't been properly vetted. Okay. The other thing you can do is open it in our verify module, where you can do you can see how it behaves, and you can see maybe why certain behaviors are happening. And then you can also instantly view it in a configurator. So you can, from within Copilot, you can be like, okay, is this what I wanted? Is this what I mean? Without having to necessarily move to a different part of the application. And I think this will be very useful for anyone who might use Copilot who isn't necessarily a full-time modeler. Currently, if you're not a full-time modeler, you tend not to use our application at all because there's too much barrier to entry. You don't want to spend too much time learning how to use it. So you leave that to the modeler. We want to get rid of that, hopefully. Okay, but this was a little while ago. Now I'm going to show another video which I recorded this morning, actually. And this shows a little bit more how we want Copilot to be more like an assistant, guiding, making the right, avoiding you having to do too much tedious data entry, and even showing a little bit how it could be a useful best practice guide. Okay, so just to get me started, I'm asking Copilot to generate a model of a helicopter, just so I have a starting model. It's unlikely that you will want AI to make up a model from scratch, but here we go. So we're getting started. I created some variables, but one of them is color. That's not really important. Now I'm going to try and add more. So I'm saying, okay, now I want to add a variable for markets, and I'm going to want to include US, Canada, and okay, just the biggest European countries. So I don't have to necessarily list it specifically, and we'll see what the AI suggests. Germany, France, UK, Italy, Spain. Yeah, that seems about right. I could always add another prompt if I wanted to change that list. Okay. Then I say, okay, I want to add a rule that restricts green to only the North American markets, and say that red is unavailable in the UK. And we'll see what it comes up with. So note that I said that red is unavailable in the UK. That's how I worded it. So it comes up with a rule. I apply this rule. We could definitely improve the UI on that. And you can see that it's created a sort of tabular rule which lists possible combinations, and you can see that red is possible in all the countries except the UK. Now this is nice because generally speaking, customers should pick one or the other way of working. So one way is you want to assume that all possible combinations are valid, and you're going to focus on excluding things and saying what isn't possible. Or you should assume that almost nothing is possible, and then you're going to list what is possible. And it doesn't really matter which one you go for, but whichever one you pick, you should stick to. Because, for example, here, if I had put in a separate rule that said no red in the UK, if I then later on added another market, red would automatically be available there, and I would need to make sure that it really was. So it depends on which way your company thinks, and it doesn't really matter which way, but you should stick to one way. Okay, so then I ask it, add the color orange and make it behave like red. This would be a common kind of thing when you have an update or a new version of a product. And here, what's great is that Copilot adds the color orange, and it automatically updates the rule that involves red and makes orange match that behavior. Okay. So then I went and found some technical documents about helicopters, and I see here that there's a list of fuel grades. So then I go, okay, now I want to add these fuel grades, and I tell it to use the screenshot. So this shows how screenshots are still useful, but maybe where you have a little bit more control, you can see exactly what it's doing. Because in the first example, it's very exciting, but even if you had a black box tool, right, where the first model it creates was 90% right from a huge version, you had no idea how much data was in there. The amount of time that it might take to work out which percentage, which 10%, which 5% is wrong, I mean, it's probably about the same time as if you had just built it a little bit more iteratively. And also product models, the data that comes in from the different departments in a company, it doesn't all come in one go. These things do tend to happen in drips and drabs. So that's what we want to support here. So then I also say to add a temperature for the ambient operating temperature. I saw it was like between -40 and 50. So yeah, it adds a numeric variable there with a min and a max. That's nice. Then I go back and I see this operating table, and I go, okay, take a screenshot of that and ask it to create a rule that indicates the ambient operating temperature for each type of fuel. Okay. Nice. It would be nice if it actually, if it showed you the rule, but we'll definitely get there. It doesn't render the rule super well, but you can see here that we've got a tabular rule, and that for example, the last one, the Russian standard one, it gives the entire range, and that matches what it says, no temperature restrictions. So then I pick another one, JP8, not approved below -32, and you can see there that it's gone from -32 to 50. So it's worked pretty well there. Okay, so that's the end of the video. But now I want to basically leave you before questions with what we want our Copilot to be, which is AI-powered modeling. You can do it smarter and you can do it faster, but don't worry, your product models will still always be accurate. Okay. Yeah, I guess we're open to questions.
Yeah, we have questions here. Let me go through them. I think we have a couple minutes. We're a little over, but let's see. Okay. How is Copilot different from using ChatGPT to generate code?
Oh, right. Okay. Because we have the domain-specific knowledge in there, right? I mean, if you had to ask ChatGPT to generate this, you'd have to explain, I mean, everything to it. Yeah, the part about having best practices built in, about having the domain-specific knowledge already built in, is going to be hugely valuable. Yeah.
Great. I'll do one more. How does this scale for highly complex product configurations?
Well, the UI needs to improve a little bit for that. But what you can see in that second video that I showed you, from the AI's perspective, it doesn't really matter how big that model. I mean, I started that helicopter because it was small, but it doesn't matter how big that model is. It won't make any difference if you're adding a variable to a model that has 10,000 variables already or not. It makes almost no difference. Then, okay, how if you have, where I said add the color orange and make it behave like red. If red is is used a lot, it has to do a little bit more work. But there's no reason why the AI can't find all the uses of red and mimic it for orange. So it won't scale with the initial video that I showed you, because there, if it scales too far, the problem is that you just don't have the time to find out how accurate the AI was. You'd have to go through everything by hand to check if you want it to be 100% sure. But in the second video where I showed the iteration, Copilot isn't about replacing modelers. That's not the point. It's about helping modelers and everybody else at the company as well to be able to model and to know what they're to do it fast, but to know what they're doing. It's a co-pilot, right? AI isn't about replacing you here. It's about making you more efficient, basically.